Hello and welcome everyone to the webinar number 26 of our knowledge series between HC and TSJSI as part of our India EU ICT Standards project. And today we are going to discuss the topic of RAN 5G NR radio evolution. And to discuss this topic, we have Mr. Balash, who is the current chairman of 3GPP RAN, TSG RAN. So welcome, Balash. And just a brief background of Balash, Mr. Balash Pateni, who is from Nokia, and today is in the capacity of chairman of 3GPP RAN. He holds an MSc degree in computer science and telecommunications from Technical University of Budapest, and he has over 20 years of experience in the field. He joined Nokia in 1998, and I think has been working since then with Nokia. And also, Balash has been also quite active in the standardization space. I can see from the timeline that he has already started his work since 2000, and working his way up. He was already chairman of 3GPP SA2 from 2007 to 11, and then 2011 to 15 for 3GPP TSG SA, and he was re-elected 3GPP TSG RAN chairman in 2019, starting from 2017. So a warm welcome again to you, Balash, to our webinar today.
Thank you very much.
And to do the context setting for our webinar today, we have Mr. A.K. Mittal from TSJSI. As many of you would know him, he is looking at the 5G topics and has been, helping us build the conversation. And this webinar, Balash in particular, we are calling this as a 3GPP standardization at 3GPP series. And your webinar is the third one in this series. We already had your colleagues, Jorg and Lionel, covering CT and essay topics. And Mr. Mittal has been kind enough to join us for the previous two webinars. And just very briefly about Mr. Mittal, for those of you who do not know about him, he has worked in almost 44 years in the field of telecommunication, and he did his graduation from famous IIT Roorkee, and he has been working with the government looking at variety of topics from satellite communication, mobile networks, network management, and so on and so forth. He's also quite well versed with the topic of standardization and has been actively participating in 3GPP meetings and helping TSSI navigate the ways of standardization. So a warm welcome to you, Mr. Mittal, and I hand it over to you to build today's conversation on the topic of 3GPP RAN.
Thank you, Sachin, for the kind words, and good morning and good afternoon to the participants in different parts of the world who are here. And this webinar is basically, as you see from the topic, 3GPP RAN, the home to 5G NR. It is very rightly worded, because radio access network is the basic or the part of network which makes the mobile services becoming available to the public, and the kind of evolution of services which you all have seen has come because of the innovations which have happened primarily in the radio access network part. So, and currently we are the 3GPP is in the 5G domain, which was finalized and started with release 15. Release 16 is going to be frozen soon. Mr. Balash will bring more light into that, and about release 17. The focus of this has been more on the kind of services which can be delivered to different verticals, and industries. Of course, it will make difference to the individual phone holders also for a variety of reasons. But the basic difference will be felt by different vertical industries that you will come to know when you hear from Mr. Balash. And I have been to RAN 3GPP meetings, mostly plenary meetings where I have met Balash. He may not remember me much because for him there is a crowd of 400, 500 people sitting in front of him. But I have met him, and I am a big fan of him, the way he conducts the meetings, the kind of knowledge he has, and kind of people he handles and quickly settles the matters with 300 agenda papers to be finished in 4 days' time. It's a humongous job, and he has done it very efficiently. So without taking much time, I hand over to Mr. Balash with his presentation. Welcome, Mr. Balash.
Thank you very much, Mr. Mittal, for the kind words, and also Sachin for the introduction. It is an honor for me to speak to you here today. I will try to explain to you and demystify how 5G standards are done, in particular on the radio side in 3GPP RAN. So I will present to you some of the basics, and then I will go into some of the more details on 5G standardization. So I'll first speak about the role of 3GPP, how 3GPP came to life and why, and what is its history. I'll talk about how its work program and releases are set up so that you understand how the structure and the whole organization is run. And then I said I'm going to go more into some of the technology details of what we're doing, how we're doing it. And last but not least, I would like to go a little bit more into detail of how you can actually join this, how you can actually contribute, what do you need to do, etc. So I plan to have this presentation for about 30 to 35 minutes, and I very much count on your questions. So if you do have any questions, please type it in the questions panel of the GoToWebinar application, and then I will come back to all of those questions at the end. Please don't be shy. Any question you may have is very much welcome. So starting up with the role of 3GPP. So the picture you see here on the right side is a very simplified picture of how standardization, trials, R&D, and actual deployment come together in the full picture, and where standardization is in that picture. So essentially what we do in standards is very much based on research results, but it's also based on the field experience, based on information on what is still missing from the field in terms of functionality, and also forward-looking innovation. So if I were to classify the two most important pieces of input to standards, it's exactly these two things: on the field experience from actual deployments worldwide, and research-driven innovation. So, and of course, what we do ends up on the field in products, in commercial products, both on the network side and also on the device side. What we do is that we actually provide a complete system description. So what I'm going to be speaking to you here today is mostly radio focused, RAM focused. But as you might have seen, for those of you who were there for the webinar of my colleagues on Lionel from CT and on system and services aspects from Georg, you could see that we in 3GPP provide a holistic system description from radio to core to services. So essentially, we standardize interfaces. That's the cornerstone of interoperability. And that's interfaces from the network to the device, as well as the interfaces within the network. So the latter is very important to ensure multi-vendor networks, to ensure proper competition and setup of networks, and so that operators can select the best possible pieces of network equipment and that fits their deployment plans. So this is just a quick recap of the evolution. It all started with 1G, with the analog technology. There wasn't much global standards back then. With 2G, we already had initial run with more holistic standards, at least in Europe with GSM, and that has spanned beyond Europe. But the worldwide global standards really started with 3G. And this is where the naming comes from. I mean, many people ask, why is 3GPP still called 3GPP in the era of 5G? And there's a simple answer to that. So our existence can be traced back to the start of 3G. And since then, 3GPP has become such a brand that it really doesn't make sense to change that name from generation to generation. So we're going to stick with 3GPP as an organization name and as a brand name going forward, even in 6G and 7G, etc. But really, the inception of global standards can be traced back to 3G. That was really the first initiative where all the different regional SDOs from all the different regions, China, Japan, Korea, Europe, US, came together and said, we actually want to standardize a single global system for 3G. And 3GPP was formed as a partnership project. That's where the PP comes from, is partnership project of these different regional standards development organizations. Then going on to the next step with 4G and LTE, that was really the expansion of this single global ecosystem and the single global standards idea. It was a massive success. It was essentially a success beyond anybody's dreams. And now there were several different factors playing into that success. Of course, not only the fact that we did standards, but the inception of iPhone, the Android devices, just the technology evolution that allowed all those different cellular-based applications to flourish, the app stores, etc. So there were basically many different things that played a role in LTE being so successful as it was, or as it still is, of course. But single global standards is a cornerstone element to that. And we're taking that forward with 5G, the very same approach, the very same motivation, but I would call it the same motivation on steroids. So with LTE, we very much focused on mobile broadband. With 5G, mobile broadband is still the bread and butter, but with 5G, we're going to address a multitude of other adjacent verticals and systems and use cases. And I'm going to speak about that a little bit more in detail later on. So let's look at the 3GPP standards ecosystem a little bit, our little world in 3GPP focusing on standards. How does it look like? So on the sort of top level organizational side, it's the organizational partners, the regional SDOs that do the project level coordination. So top left hand corner, the ATIS from the US, Arrive and TTC from Japan, CCSA from China, TTA from Korea, ETSI from Europe, and of course TSDSI from India, the latest edition. And we've been very happy with how TSDSI joined the project and how its members became very active and contributing in 3GPP. It has really been a success story. So that's the top level sort of ecosystem organization of 3GPP. Then we have what we call market representation partners, MRPs. So these are adjacent organizations that have a stake in the cellular ecosystem being successful. So for these MRPs, cellular is either a central or a very important part of their ecosystem. So here, just a couple of examples, 5G AA with the Automotive Association, so the vehicular industry, 5G ACIA with the manufacturing organization and industry organization. And there are many others. These are just some examples here. TCCA with the critical communications, GSA, which is the Global Suppliers Association. So essentially, these are MRPs that contribute to the success of the technical standards we do. They use, or their members, companies from these industries use the standards we make in 3GPP. And these MRPs are essentially doing marketing of our standards. So they're an important part of our success. The most critical part of the actual 3GPP standards ecosystem are then the members themselves. So 3GPP is run or is essentially driven by industry members, by companies, by corporations who have a vested interest in the cellular ecosystem. So the membership comes from the membership of all the different regional OPs. So each and every 3GPP participant, now it's more than 700 companies, or members of one of the regional SDOs. Then we have relationships with a number of external organizations that do either standards or that do activities that are related to what we do. For example, IETF for some of the internet protocols, IEEE for some of the Wi-Fi related standards. There are also the regional regulatory bodies, for example. So that is really a very, very long list. I just put an example list here on the right side that you can see all the different organizations that we liaise with and we have relationship with. So moving on to the 3GPP structure itself. So the right side, TSGCT and TSGSA, you have already heard about from Lionel and Georg, my colleagues and the chairman of those two TSGs. And today I'm going to focus here on the left side, which is focusing on radio access network and radio matters. So TSG RAN, like each and every TSG RAN has a top level plenary, and that's the where I'm the chairman. And then we have working groups within the TSG, and those working groups do all the different detailed technical specification work. The working groups is really the home for the vast majority of the detailed technical discussions. So RAN Working Group 1, they do the physical layer specifications. It's the most popular working group with more than 600 people attending a meeting. Well, that's of course when we can actually have a physical meeting. RAN 2, they do the radio protocols. RAN 3, they do the radio architecture. RAN 4 is primarily radio performance aspects, radio resource management and spectrum matters. So it's a very important group for operators as well. RAN 5, they do the testing, and RAN 6 is actually a group that we're about to abolish and merge back into the RAN plenary because the work amount with the legacy radio aspects that that group has been focusing on has gone down. So we're actually merging that work back into RAN plenary, and there's not going to be any separate working group for that work anymore. So moving on to how we actually do our work and how we structure our work in 3GPP. So essentially we structure our work based on releases. Each release contains a distinct set of features that we call work items or study items. And each release, or basically we bring out a new release every 15 to 18 months. So we have a timeline for each release that we have a strong commitment to keep, because the industry is based on the timing of 3GPP releases. So we do have a very strong commitment to ensure that we can keep the release timelines in 3GPP. It's very important from the perspective of time to market as well. So the work plan for each release is then built using a distinct set of work items. Essentially, each work item constitutes a feature. For example, MIMO is one feature. Coverage and enhancements is another feature. And each of these features, the goals and objectives of what that feature shall deliver is described in a work item sheet that then the plenary oversees and approves and changes if it needs to be changed. So if you look at the right-hand side picture, that roughly represents of how the different releases came about in terms of timing. In terms of timing, I mean, you can see on this picture that we bring out a new release roughly every 15 to 18 months. Now, some of the releases went longer, some of them were split into two, some of them were shorter. It's really the market dynamics that determines the length of a release and also the content of a release. And what you can also see here is that any given time, typically a group deals with at least 2 concurrent releases. Like if I look at where we are now at this given time, Brand deals still with release 16 finalization. It still deals with some of the release 15 maintenance, some of the aspects that needs to be changed and corrected depending on the field experience for our first 5G release, and that's release 15. But we also are starting already to look at release 17, the innovations, the new features for the next release. So how a work program is organized in RAN. So as said, if you see on the leftmost side, typically a life cycle of a release has a duration of about 15 to 18 months. And it all starts with what we call a package approval. So this is done in the RAN plenary meeting. And essentially we decide which work items and study items we approve for the upcoming release and with what exact content. So all the detailed objectives and functional goals of each and every item that we decide to include in a release is going to be decided upon this package approval. So an example, I will bring up an example also pictorially later on, but essentially for release 17, we had this package approval meeting back in December, which happened to be our last face-to-face meeting before the global pandemic hit. But we were very lucky in a sense that we actually have a work program approved for release 17 before the world has gone haywire. So we actually have a work program that the different working groups can work on. So from there, the specification work has or will start in the different working groups. Again, RAN 1, 2, 3, 4 in their own respective areas: physical layer, protocols, architecture, and spectrum. And when all of the work is done, then it's actually a plenary meeting again that does the formal freeze of the release. So that's essentially a simplified life cycle of a given release. And then in terms of the schedule of the meetings and how the technical work is being progressed, it has a quarterly rhythm. So we have a plenary meeting each quarter. So we have March, we have June, we have September, and we have December. So we have 4 plenary meetings each year. And those are the ones that steer the technical work. Those are the plenary meetings are the ones that make conscious decisions on technical direction. This is where some of the contentious items get elevated to from the working groups. So essentially, if you participate these quarterly plenaries, you would get a very good idea of what's going on the technical level and what's going on the strategic level, both backwards and forwards for the different technologies and releases. And then the working group meetings are then scheduled within the quarter between the 2 plenary meetings. So, like for example, for the 4th quarter, what we would have had we been able to do physical meetings, we would have had 2 sets of working group meetings, one in October and one in November. Now, unfortunately, again, the way the world has gone, we had to move these to electronic meetings, and then we actually combined them into one. But then the main thing to remember here from this slide is the overall rhythm of 3GPP that spans across plenary meetings once every 3 months, and then working group meetings between the plenaries. And our decision making is essentially consensus based. So what that means is a proposal or a document or work item, whatever that may be, can be approved if there's no sustained objection. Now that's sometimes very difficult to do with several hundred people and companies in the room. So if we cannot achieve full consensus, we do have means to actually go forward. We have methods to take working agreements, for example, that would then based on a vast majority. So if the number of objections is reasonably small, normally also the members act reasonably, so they withdraw their objections if they see that they're in a very small minority. So 99.9% of our decisions are actually made by consensus at the end of the day, even if there were objections or concerns at the beginning of a discussion. So moving on to some of the 5G related details and how 3GPP has gone about 5G NR standardization, in particular in RAN. So this triangle here on the right has been beaten to death. So I'm sure all of you have seen this. All of you have seen many different iterations of this. What I would maybe focus a little bit more on is the way I see at least 5G is essentially a perfect storm of some key technology trends that are emerging. So first of all, the availability of reliable low latency radio and a fully flexible network. So this is the availability of a capable radio that can do a whole lot more than LTE could in terms of latency, reliability, capacity, frequency bands. And from an architectural perspective, this is a radio network that has the flexibility to adhere to all the different potential deployment needs and requirements that can emerge anywhere in the world. So what we have seen with each and every generation, that the flexibility has to grow. Like back in 2G, you had a base station, you had an MSC, and you had a VLR, and pretty much all the deployments were very much like each other. Now, as the architecture developments have gone forward with 4G, and now especially with 5G, with cloud radio, and with all the different deployment needs, we really need all the flexibility we can get from the architecture to make sure that each and every operator, vertical, and deployment scenario can make maximum use of 5G going forward. So that's where the flexibility is essentially crucial, and that's where the standardization of all those different interfaces between those elements of that flexible architecture is important. The second element is artificial intelligence and automation. Now, 3GPP has a big role in O&M and some of the automation capabilities in O&M. But in terms of artificial intelligence, what we do is more like an enabler. So we don't in 3GPP specify like AI algorithms or what certain AI elements and program blocks in the different elements should do, but what we do is enable those by collecting the necessary data. So we have work in 3GPP that addresses the data collection needs and addresses how the different pieces of data can be collected to drive those AI and automation processes all through the network. The third element is really device revolution and augmented reality and virtual reality. And we're still in the infancy of that. I'm sure many of you have tried some of those glasses and virtual reality glasses, and I've tried some of them in the past in some of the conferences. It's mind-boggling what that device technology and device evolution will be able to do, especially if and when the form factors become more human. So some of those glasses are still very bulky and huge, and when they become smaller and truly more usable from a human perspective, it's really limitless what that technology can do. And last but not least, from the 3GPP perspective, perhaps the most important trend is that vertical industries and adjacent industries are going cellular. So many of the industries that are used to either using wired technologies or are not used to using any communication technology in the past are now seriously looking at using 5G to boost their business, to boost their operations, to boost the way they actually go about their daily doings. So in particular, some of the examples are critical communications, vehicular industry, manufacturing industry, agriculture, satellite. So the number of industries that have realized that 5G could really bring them a true benefit is growing by the day. And for us in 3GPP, this is perhaps the most important trend This is also reshaping 3GPP because we used to be primarily telecommunication members, either vendors, operators, or device vendors, but that mix is becoming infinitely more versatile now with the inclusion of vertical participants in industries. So if I look at the 700 plus members we have, at least 1/3 of those members are now coming from not from your typical telco industry, but more from adjacent vertical industries. So a quick word on the timeline specific to 5G. So as I mentioned, our work in 3GPP is structured into releases, with each release taking about 15 to 18 months. Now, the first 5G release in 3GPP and 5G Phase 1 was Release 15. And in Release 15, we very much focused on addressing the most urgent 5G deployment needs. So Release 15 was very much focused on enhanced mobile broadband. It was very much focused on addressing some of the capacity shortcomings in several regions with 4G, like in particular, for example, in some of the bigger cities like Tokyo, LT was really running out of capacity. So there was a very urgent need to boost that mobile broadband capacity with 5G, with new frequency bands, with the new radio. And Release 15 was primarily addressing this most urgent need. We actually did Release 15 also in two subphases, with the initial phase focused on what we call non-standalone deployment, so deployment where you would still have a LTE anchor and then you would use 5G as a capacity booster secondary cell in your network. And then the second subphase of Release 15 brought the fully standalone 5G to the standard. So essentially, with Release 15, you could already deploy a fully standalone 5G without the need of an underlying LTE network. In particular, in China, for example, the 5G standalone deployments are already very much underway. Like from the very beginning of this year, you can only bring a device to China that supports standalone. So standalone has been also very much a success story and very much sought after in different regions and markets. And then with Release 16, which is very much the release we are about to finish, and I'll get back to that in a second, but with Release 16, we are focusing on two main objectives. One is to complete all the standards that are necessary for the IMT 2020 submission. So that is essentially ITUR's global standards for IMT 2020, and 3GPP's 5G NR will be the key submission, the key technology submission there. And then the second element was to expand our 5G platform beyond mobile broadband. And I get into more details in that in a second. And then in phase 3, from Release 17 onwards, we really focus on fulfilling the entire holistic 5G vision, the entire triangle, essentially, and all the different permutations across the different edges of that triangle. So, as said, I'll explain the ongoing releases a little bit more in detail so that you can actually see how we go about the details on the radio side. Now, the way this picture is structured is per releases. So the green part on the top is Release 16. The red part in the middle is Release 17. And then that little pink box on the bottom is some initial thoughts on how we will actually go about starting Release 18, so the next phase of evolution. So as you can see from this, we're right now at the end of Q2 of 2020. We're about to freeze Release 16. We're about to freeze both Stage 3 and ASN1. ASN1 is the protocol notation on the radio side. So essentially, we're about to finalize Release 16. Some of the RAN 4 radio performance work typically comes 3 to 6 months later. That's very much the normal process. They need the full system to be standardized before they can finalize and determine the exact radio performance requirements. So that's very much a typical way of working. Then with release 17, as mentioned, the package itself was approved back in December 2019, and that's the first red box on the left side. And from there, we add the RAN 4 package now and in September. And as you might imagine, the ongoing pandemic situation does have an impact on our release 17 timeline. What you see here is an initial 3-month shift already, which would put the RAN 1 freeze to June next year. But it's quite likely that this timeline will slip a bit further depending on the global pandemic situation and when 3GPP come back to physical meetings. As you have seen from the explanations before, our work very heavily depends on physical meetings. It very heavily depends on people being able to come together on a periodic basis, iron out technical disagreements, make key technology decisions. And some of those things are just very difficult to do in a virtual setting. Now, we do, of course, as I will explain a bit later, have virtual meetings. So the world and the work hasn't stopped. We very much are pushing forward with the standards work in 3GPP, also under the circumstances. But because of the constraints, the speed is slightly slower than what we're used to with physical meetings. So this slide then explains the key 5G technology areas going forward. And I really try to structure this slide so that on the left side, you have features more related and driven by mobile broadband. And then on the right-hand side, you have actually elements, and the bottom of the left-hand side, you have elements related more to verticals. So starting from the upper left-hand side, continued enhanced mobile broadband enhancements is still the bread and butter of 5G. A part of our work program is still very much dedicated for this piece of work. If I want to give you a proportionality, it's roughly about 30 to 40% of what we still do in release 16 and release 17 is very much driven by and focused on mobile broadband. Now, this does not mean that those functions can only be used by mobile broadband. So that's why that proportionality is a bit misleading, because many of the things we do for mobile broadband are very useful for verticals as well. Things like mobility and coverage enhancements. Like typically, if I look at India, coverage enhancements is a very important piece of work that we do and continue on doing. And that's not going to be relevant only for mobile broadband, but for IoT, for example, as well. Then we're looking at NR multicast with release 17. We're going to standardize a multicast platform for 5G NR. Satellite, as I mentioned, is also entering the picture now with release 17, and we're actually going to address both mobile broadband as well as NB-IoT over satellite access. Enhancements to industrial IoT, some of the initial work we've done in release 16, and then with release 17, we're going to enhance that platform to make sure that what 5G NR brings is really very well usable for the widest range of industries, manufacturing industries. We're further expanding the sidelink work. Sidelink essentially means that it's a direct connection between devices without the involvement of the network. So we have uplink, we have downlink, and we have sidelink. So that's where the terminology comes from. And this direct device-to-device communication is essential for some of the key industries, for example, in the vehicular space. So that's V2X, where cars could directly communicate with each other, for both for safety as well as for some enhanced use cases, and also critical communications when you have police or disaster relief activities out in the wilderness where there is no network coverage. You really want this device-to-device communication to be enabled between officers. Then if I look at the right-hand side of this circle, unlicensed spectrum is also a piece of functionality that is primarily important in the industry space. So, for example, if in a factory, a bigger factory, it is very much possible to use purely unlicensed spectrum and unlicensed operation for 5G NR for all the manufacturing and whatever needs that particular factory has. So unlicensed spectrum operation is part of a 3GPP work program. It's going to be, most of it is going to be finalized already in release 16, so it's going to be available. Some of the elements we might still need to fine tune in release 17, but the vast majority of unlicensed operations support is going to be available with release 16. Then, as we have seen, there are new device types, not only these glasses, but also things like wearables, things like industry sensors, things like security cameras. So with 5G, we're seeing an expansion of device types, and we're trying to make sure that the technology we provide gives an ideal cellular component for all of those different device types. So we are conducting some work in release 17 to make sure that we have all those different capability subsets enabled for all those different device types that we clearly see emerging. Now, positioning, so cellular technology-based positioning has started already with release 16. We have positioning accuracy of about 3 meters, but now we're bringing that down with release 17 to what we call a centimeter level. Now, centimeter level might be a little bit ambitious, but we're actually looking at about a 30 centimeter accuracy, and also indoor positioning possibilities, again, for the different factories. So that's something we're addressing in release 17, along with expanding the positioning, the number of devices that can use positioning, so that the positioning technology can scale to thousands, 10,000s, and even millions of devices in a smaller geographic area. Extended reality, I have already spoken about. That's from a commercial space, that's probably the most important element of 5G. And last but not least, we are seeing a vast majority of 5G deployments in all the different regions already, and we are getting feedback, we are getting experience with the deployments, we are getting learnings. So all of those elements we are feeding back into the standards process and correcting, adjusting some of the technology elements as we see needed from different on-the-field deployments. So a few words about how this ongoing pandemic is affecting us, so that you get the full picture of what is going on today in 3GPP. So first of all, what has become apparent during this pandemic situation is that the role of cellular networks has perhaps become greater than ever. The role of connectivity, the role of being able to communicate, share information has become greater than ever. How does this pandemic situation impact 3GPP? I essentially brought to you two pictures here to give you an idea. So this would be a typical meeting, what you see here, with hundreds of different people from hundreds of different companies at the same physical location. And this is how we used to work up until last December. But now this is how we work today. So we essentially use the very same tool we use here today. We use GoToWebinar. GoToWebinar is our main online tool during the meetings for conducting technical discussions. But besides that, of course, we have email as the other essential pillar for conducting work in a virtual setting. So if I look at how a typical meeting used to be, in this setting, we had a working group meeting or a plenary meeting that ran for a week, from Monday morning to Friday evening. We went through all the technical contributions. There were a lot of on-site side discussions between companies and delegates. And by Friday, we basically completed all the technical work there on site. Now, in a virtual setting, we are looking at longer meetings than 1 week. In particular, for the working groups, we're looking at 2, sometimes 3-week-long meetings. And even then, the amount of work we do is about half, maybe 60%, simply because of the lack of physical interaction, the inability to iron out technical details in evening drafting sessions in some of the smaller rooms, etc. That's the biggest thing that we're missing. But the key point here is 3GPP is very much progressing and going forward and doing its job to the best extent it can, also in a virtual setting. And last but not least, I would like to talk to you a little bit about how you can join this, well, I would call it traveling circus, but we're not traveling at the moment. Essentially, how can you join 3GPP standards work? So step number one is that you really should join your regional organizational partner as DEO. So for companies typically residing in India, this would mean you would need to be joining TSDSI. Now, different OPs have different membership structures. I'm not going to get into that, but you can get information on that from TSDSI on how your membership, how the membership structure is. But essentially, the first step for you to come to 3GPP meetings, to make technical contributions, to participate technical discussions and shape the industry is to join your regional SDO. Once you did that, you basically need to gauge the amount of involvement that you see necessary to get the most out of 3GPP for you. Now, for some companies, this stops at monitoring. So then you only really need 1 or 2 people to come to the plenary meetings and monitor what's going on, and maybe drive some of the top level technology discussions, schedule discussions, things you can do in the plenary. That's one end of the spectrum. The other end of the spectrum is if you really want to influence the in-depth technology choices, technology directions, you really need to send people to working groups. And that's where the need for staffing this work increases to 5 to 10 to 15 people and beyond, depending on which groups your particular company and corporation would have a stake in. So again, your participation can vary anywhere from a 1-person monitoring to a 10, 15, 20-person in-depth technology influence in the working groups. Really, the minimum involvement is to participate at least the plenary meetings. And that's RAN and SA for radio. So if your interest is primarily in the radio, that would mean RAN. And you could come to the RAN plenary, and then you could basically participate in the top-level drive of the work program, the key technical decisions, etc. So that already gives you quite a bit of value only with a 1-person involvement. Then if you want to influence the detailed technical work, you really have to go to the working groups. And essentially for us, perhaps the most important working groups where the vast majority of the technical work gets undertaken is RAN 1 for the physical layer. That's a group with 600 people. And then RAN 2 for the radio protocols, that's a group with about 200 people. From the perspective of operators, also RAN 4 is important because that's where most of the spectrum standardization work is being done. So if you have interest in spectrum, specific spectrum bands or spectrum band combinations, you would probably have to get involved also in RAN 4. But the main message here for me today is get involved. This is an open body. You're very much welcome. The culture is a welcoming culture. If you basically come to the meeting and you contribute and people realize you have an in-depth technical know-how, you immediately will be able to exercise influence. So start attending the meetings and start writing contributions. That's really the way to do this. And again, we're very much looking forward to welcoming new members. The leadership and also most of the company delegates are very much having a welcoming attitude. So you're going to get help. You're going to get help from me. You're going to get help from working group chairs, from seasoned delegates. So it's really up to you. From our perspective, we're very much welcoming the new members and new contributors. So a quick summary of everything I've said so far. So 3GPP is really the key standards body for 5G, as you have seen, also from the history and from what we do. It's very much industry driven. So what we do is driven by the key industry players, corporations, companies who have the highest stake of this ecosystem becoming or continuing to be successful. and any company can join. So the more, the better. The wider range of companies we have, the better the chances for 5G to basically establish the widest possible footprint. So this is what I had in mind for today, and thanks very much for your attention, and I'm open to answering your questions.
Thank you, Mr. Balash, for such a comprehensive view of 3GPP functioning and work plans and features of the releases, and then how one can make impact in 3GPP by making contributions and influencing technology decisions. So I think the people who are here attending, they would have got a very top view and in a very logical fashion. So now we have some questions for Mr. Balash. I will take them one by one, and if time permits, then I may have one or two questions from my side. So the first question, if I can call it interesting, I will read out. In many countries, there is huge political pressure to connect rural and remote, for example, small islands, areas about 3.5 billion people around the globe. What will be the solution for these often low populated areas, considering often low income population and investment, O&M cost, theft of equipment, batteries, diesels, and towers?
So this is an excellent, this is an excellent question, and actually this is an area that we are very much focusing on in Release 17 with coverage enhancements work and also the satellite work. So I would basically see these two elements as key pillars for connectivity in sparsely populated areas. Now, in terms of coverage enhancements, I would also be hoping that we would get technical contributions and drive and use cases also from companies from India, because you basically know the requirements and your geographical setup better than anybody else. So essentially, we do have these features already open, and will be started in 3GPP with Release 17 very soon. And again, I would like to encourage you to participate this work from India, because we're very reliant on in-depth understanding of what exact scenarios we need to address. And we have members from Australia as well, for example. They have similar requirements given their geographical setup. So there are a good set of like-minded companies already active in 3GPP, a very good nucleus. And I think the better we can formulate requirements, the better the chances for the proper technology to be developed, either under, well, actually both under the coverage enhancements work item and also under the satellite work item.
Okay, so should I go to the next question? Yeah, next question is, maybe it was the same, to add with solution means standard. No, the question, I think second part of the question was to add with solution, I mean standards related solutions. So I think you already replied that part also. It was. Next question is,
yeah, maybe I can
yeah, you can
expand
please,
on that just a little bit. The specific technical solutions, for example, within the coverage enhancements area, that is just going to be started now. So it's an open field. So if you have specific technical solutions in mind that you believe adequately addresses the needs, now is the time to contribute and get involved. Please go ahead, sorry.
Yeah, right. So I go to the next one. What is the stage 3 work in RAN?
So stage 3 work, so essentially SA and CT, they are organized based on this staged approach. So stage 1 is the requirement, stage 2 is the architecture, and stage 3 is the protocol. And they SA and CT have their working groups set up according to these 3 stages. Now in RAN, we don't have this rigid staged approach. So for example, RAN 2 for the radio protocols, they do both stage 2 and stage 3 almost concurrently. So essentially for RAN, stage 3 is of course the protocol definition itself. If I look at radio in particular, for example, RRC protocol, the radio resource control protocol is perhaps the most important protocol for RAN. And there, RAN 2 does both the stage 2 and also the stage 3 definition. So stage 3 for RAN is essentially an ASN1 notated protocol that we get as a result.
Okay. So the next question is, what features NTN are being covered in release 16 and release 17?
In which area was that again? In what features?
It's called NTN, probably non-terrestrial networks.
Yeah, so that's the satellite.
Yeah.
Yes, indeed. So that is the satellite area. So in release 16, we conducted informative studies. So we don't have anything normative coming out of release 16. We did all the technology studies starting from channel modeling to identifying potential protocol enhancements that are needed, etc. We did that study in release 16, and now in release 17, we are going to do normative specification work. Now, the initial focus is going to be on enhanced mobile broadband support over NTN or over satellite. But we are also conducting a study on NB-IoT over NTN, so narrowband IoT over satellite. We haven't really done any work on NB-IoT over satellite yet, so this study is going to be the first phase. Whether we're going to be able to do only the study in release 17 or also normative work for NB-IoT over satellite, that remains to be seen. But at least for the enhanced mobile broadband support over satellite, that's going to be part of release 17 already in a normative fashion.
Balash, I have a supplementary question on this. When we say non-terrestrial networks, so one is the satellite, as you mentioned. Other can be low altitude or high altitude platforms, HAPS. And
Yes.
satellites also have different levels of orbits, low Earth orbit, medium Earth orbit. So is there any study going on that, or what are the possibilities in those areas?
So essentially, we did some analysis on this, and what we understand is that HAPs are implicitly going to be covered as well with this work. So the enhancements we may be doing for the physical layer or the protocols will also fulfill the potential needs of HAPs. Like some of the operators, some of the terrestrial operators are very much interested in deploying HAPs. So there is a good nucleus operator community in 3GPP that is driving this. But again, the approach we're taking is there's going to be the same set of enhancements that will fulfill all those different needs, let it be HAPs or let it be satellite, going forward. Now, that's actually a generic approach that we try to apply in most cases for the verticals. So we're basically trying to get away from vertical specific niche enhancements, because those just will not reach the economies of scale. We might be able to do specs for it. Yes, that's pretty easy. The more isolated it is, the quicker the work will go. But they will never see the light of day in commercial settings, because it's the economies of scale, the numbers are so small. Instead, what we're trying to do is enhancements and functionalities that can be used by the widest possible number of verticals. Now, that means that we might not be able to be fully optimal for a particular vertical, but you're going to get chipsets, because it will make sense for the chipset makers to manufacture chipsets, because they can be used for a wide variety of verticals as opposed to one particular one. So that's a generic approach, and that's an approach that is also apparent in the case of HAPS and satellites.
Thanks, Balash. The next question from audience is, in India, there has been a lot of focus on rural deployments. Do any of the WIs approved for release 17 address this topic directly or indirectly?
Yeah, I guess that was similar to the first question. So again,
Right.
primarily the coverage enhancements and potentially some of the satellite related work would be relevant here.
Okay, so I think our time is getting over. I can quickly take one question. Are there items relevant to mission critical and FRMCS in release 17?
So mission critical is one of the key verticals that came to 3GPP already for 4G. So we have done enhancements already to LTE to support mobile broadband for mission critical. And now we're also doing that for 5G. As I was explaining, one of the critical elements for mission critical is this side link. So this ability to communicate directly between devices without the involvement of the network. So that's one key element for mission critical that we're doing for 5G. The other key element is multicast. The multicast ability is also important. So with these two main components, and of course the adjacent system level components that SA and CT will do on the system level, by the end of release 17, we will basically have a 5G system that is fully capable to support the mission critical needs as well.
So if Sachin, you can permit another 5 minutes to us, there are some good questions and one or two good questions can we take?
Yes, please.
Thank you. And Balash, if you are okay, we can take these questions.
Sure. I'm very much available, please.
Oh, thank you. The another is India was one of the first country doing multi-SIM. I think it is being considered in release 17. What is the status?
Yes, it's a very good question and a very good observation. So indeed, multi-SIM work has been added to release 17. Now, we know that multi-SIM devices have been around for, especially, I mean, India is the bedrock of the multi-SIM ecosystem. So multi-SIM devices have been around already without the explicit standards work. So we have never done any explicit standards work for multi-SIM. The devices that have been out there are basically doing multi-SIM setup in a proprietary manner, and that's of course possible to do. Now, there are a few things that don't work in an optimal fashion in those proprietary setups, and that is why we're addressing multi-SIM for 5G to make sure we have an optimal operation of multi-SIM devices, in particular in the area of paging. So that's one key area that we are going to address in release 17, but also some of the system level aspects of multi-SIM are going to be addressed in release 17. So yes, it is part of the release 17 work program, and we're going to get it done with the release 17.
Next is are the topics to enable RAN virtualization, particularly with respect to O&M and orchestration in the scope of 3GPP.
So as I was trying to elaborate, so the flexible architecture is very much driven by Cloud RAN and virtualization elements. Now, what we do in 3GPP is try to make sure we have interoperable standards for all the key interfaces that enable virtualized and cloud deployments. Now, 3GPP is not the only body that does work in this area. For example, in the area of front haul, there are some other organizations that do specification work, ORAN in particular. So 3GPP is not the only body that you should be looking if you're looking at virtualization and cloudification, but there are some adjacent ones as well. But again, what I can confirm that at least from a 3GPP side, for the area that is under our responsibility in terms of interfaces, we are creating multi-vendor interoperable standards for those interfaces to maximize the opportunity for such deployments.
Mr. Mittal, any further questions?
Sorry, I was on the mute. Yeah, so this is the last question, and there are actually two, but can be clubbed into one. They are dealing with the same matter. Whether release 17 will consider GSO or NGSO, and also are these bent pipe satellites or G node B on satellite?
Say that again. Sorry, it was breaking
Yeah,
up.
so the question is whether release 17 will consider geostationary or non-geostationary satellites, and are
Both will be
they?
considered.
Oh, okay,
Sorry,
so they will. Could you get the
sorry,
question?
sorry. Please go ahead.
Yeah, could you get this question of GSO and non-GSO?
Yes, so both are going to be considered. Yes, in the NTN work.
Okay. And second part of the question is, are these bent pipe satellites or G node B on satellite? Bent pipe normally would mean that they are transparent. Whatever you send, they just amplify, reprocess, and send it back. Or it is a full node G node B on satellite.
So this has been discussed quite a bit during the study phase that I mentioned. We basically have looked at both, and both are part of now the work that we do. Whether we're going to be able to do both kinds or both options or both alternatives, that remains to be seen. But both are very much on the radar of what we're doing in this area.
So I think we are leaving one or two questions, and they can be, Sachin can say that whom to direct those questions and can be sent to Balash. So in the interest of time, I thank Mr. Balash for patiently and very comprehensively answering all the questions and presenting the whole 3GPP matter and our RAN and 5G issues to the audience. Now I hand over to Mr. Sachin for the closing remarks.
Thank you, Mr. Mittal. I think Balash was very correct in making observations about questions in the beginning of the seminar or the webinar. And Balash, I think you have taken the question in a very, I would say patiently, and I've already received some praise over WhatsApp from my team leader from South Africa, Andreas Soma, and he was telling me already very good webinar. So thank you very much. Mr. Mittal, there is one question which I have received on WhatsApp from C. Dot from Prakash. I don't know if you have seen that question. Is it okay? We can take, if an OEM says release 10 compliant, do they implement all features? Balash, I don't know if you can take this last question.
Yes, can you please repeat again?
If an OEM says release 10 compliant, do they mean they implement all features of release 10, for example?
That's a loaded question, to be honest, because it's more a commercial question than a question to standards. Like typically, what has like back in the GSM days, these implementation questions were very monolithic. Basically, a new version of the standards came out. Network vendors and device vendors implemented the entire release, and then there was a new software version, and then that got installed, and everything was of course standards compliant with the new release. Now, as things have gone forward, things started to get more and more cherry picked. So, for example, some elements of the release never get implemented anywhere. Some elements of the release get implemented from a previous release. Some elements get implemented from a new release. So I think this generic question of an entire release being implemented or not is not it's not really possible to answer. I would probably say no, because nobody really implements an entire release with all its functionality anymore. Lots of the things that are in standards are either optional or conditional. I think for that question, we probably need to understand what functionality that question relates to. So, for example, if there is function A, so did an OEM vendor implement function A as per release 10 specifications? That's something we could answer, or somebody could answer. But in terms of implementing the entire release, I think those questions are disappearing essentially. I hope this answer made sense.
Thank you, Balash. I think it does answer the question. It makes sense what you said, and I think it also fully doesn't fall. Also, the onus doesn't lie with the standards people entirely, as you said. It's also with the company implementing. So we have taken more than 11 minutes than we planned, and Balash, it does. Kind of make Mr. Mittal's prediction true that your topic is the most popular topic among the standards people. So we are immensely grateful to you. I think you have conducted, as Mr. Mittal said, as always, a really good webinar. And we look forward that if we could engage you in future, because increasingly this topic of 5G RAN is coming up here in India, and hope we can get your support in future that you can make 3GPP more accessible for the community to contribute and participate.
Absolutely, and this has been my honor to talk to you today, and I would very much welcome similar activities or even more direct and specific activities to help new members become active in 3GPP. So really, thank you very much for having me.
Yeah, our pleasure. And I also thank, in the same spirit, Mr. Mittal and our participants today. And we would be having this slide deck, available also on our website. And also the recording would be available on the YouTube channel. Thank you, everyone. Again, have a good day.
Thank you. Thank you. Bye-bye.
Thank you, everybody. Bye.